Good evening. I would like to wish you all a Happy New Year. Thank you for following me on Twitter and also for watching this monthly programme. We have some exciting news. China has successfully landed Chang'e 3 onto the surface of the Moon, which carried a lunar rover, affectionately known as Jade Rabbit, the first to go there in more than 40 years. Sadly, on December 9th, China's high-resolution remote sensing satellite, Xi'an I-03, failed to enter orbit after its launch. The following day, China had another disappointment when the Chinese Seabird 3 satellite failed to enter its designated orbit after being launched from the Taiyuan spaceport. The satellite was a geostationary remote sensing satellite jointly developed by China and Brazil. So we are indeed very fortunate that Chang'e 3 has been so successful. In Chinese folklore, Jade Rabbit represents a companion of the moon goddess Chang'e, and instead of pounding the mortar and pestle, the rabbit is pounding the elixir of life for the goddess. The moon rabbit in folklore is a rabbit that lives on the moon. It is based on naked eye views of the full moon, which identify the markings of the moon as a rabbit. The story exists in many cultures, notably in East Asian folklore and Aztec mythology. The last rover to land on the moon was a 1,900-pound Soviet vehicle known as Lunokhod 2 in January 1973, just a year after Apollo 17, the last American manned mission to the lunar surface. Apollo 17 landed in the Torov-Litrov area of the moon on the lower eastern side of the Mare Serenitatis, the Sea of Serenity. It was Apollo 17 astronaut, geologist Harrison Schmitt, that found orange soil on the moon, which was later found to be composed of millions of glassy beads. After analysis by NASA at Brown's University in 2011, the soil demonstrated that there was water locked up within the basalt lava flows which make up the surface dust and rocks of the lunar seas, which are emanating from within the moon itself. The discovery by Albert Seil, Associate Professor of Geoscience, and Thomas Weinrich, his assistant, are important to planetary scientists. The Chinese rover Jade Rabbit landed an interesting lava field, so its findings over the next 12 months will help to confirm the Brown University discovery by analysing the basalt rocks and soil samples during its travels. In this programme, we examine the mission in detail from launch. Today, Jade Rabbit is asleep on the surface of the moon on the northern edge of the Mare Imbrium, which is Latin for Sea of Showers or Sea of Rains. The landing site is in darkness, with the sun below the horizon. Sunrise will be on January the 10th. The Taiyuan Satellite Launch Center, also known as Base 27, is the People's Republic of China spaceport located in Keelung County, Zhengzhou, Shanghai Province, northwest of Taiyuan near the Soviet border. The facility became operational in 1984 and is primarily used to launch powerful rockets and geostationary communications and weather satellites. It is notable as the site of the Sino-European Space Cooperation, with the launch of the two first double-star scientific satellites in December 2003. The Chinese have paid a high price under the development of their launch vehicles. In the mid-1990s, two fatal accidents occurred when rockets failed to launch from the Taiyuan spaceport. On January 26, 1995, a Long March 2E rocket veered off course 2 seconds after takeoff and exploded, killing at least 6 people on the ground. On February 14, 1996, a similar failure during the launch of the satellite Intelsat 708 occurred. The rocket veered severely off course after clearing the launch tower and landed in a rural village. Following the disaster, foreign media were seconded into a bunker for 5 hours, while some have alleged that the Chinese military attempted to clean up the damage. Officials later blamed a gust of wind. Exxon news agency initially reported 6 deaths and 57 injuries. In the aftermath of the explosion, US satellite makers shared information which allowed the Chinese to determine that the problem was in the welding of some of the components in their rockets. The Taiwan spaceport consists of 3 main launch pads that were constructed in sequence as the rockets became bigger in size, and a technical centre which is equivalent to NASA's Vehicle Assembly Building. It is state-of-the-art and is equipped for testing and the integration of the payload and the launch vehicle. Its Mission Command and Control Centre is located 5 miles southwest of the launch pad and provides flight and safety control during the overall system rehearsals and the launch itself. It is serviced by a dedicated railway and highway directly from Taiwan Qingshan Airport, which is 31 miles away from the site. The Chinese know a lot about rockets because they invented them. The ancient Chinese were the first people to invent gunpowder around the 9th century AD. After its invention, gunpowder was soon applied in warfare. By attaching a small gunpowder propellant onto an ordinary arrow, the Chinese created the world's first rocket. The first of the Chinese March rockets or launch vehicles is the Long March 1, whose second flight sent China's first satellite, Dongfang Hong 1, into orbit on April 24, 1970. The vehicle made only 3 flights until March 3, 1971, when it was retired. It is a 3-stage rocket, 98 feet tall, 7.5 feet in diameter, and was capable of carrying a 660-pound payload into Earth orbit. Altogether, there are 11 March vehicles in the March family of Chinese rockets, including the Long March 3B, which launched Jade Rabbit to the moon. The Long March 3B, also known as the CZ-3B and LM-3B, was introduced in 1996. It is launched from the Launch Area 2 at the Taiwan spaceport. A 3-stage rocket with 4 strap-on liquid rocket boosters, it is currently the most powerful member of the Long March rocket family and the heaviest. It is mainly used to place communication satellites into geostationary orbits. At the time of its introduction, the Long March 3B was the second most capable expendable launch system in the world after the Russian Proton. The March 3B is a 3-stage rocket, 180 feet high, 11 feet in diameter, and weighing 940,000 pounds, about 460,000 kilograms. The Change 3 probe consists of 2 parts, the lunar lander and U-2 rover. With a mass of 2,600 pounds, the lander has been described as massive, and it also carries a 260-pound rover, Jade Rabbit. It serves 2 purposes, since it is also a technology demonstrator to be further refined for the planned 2017 Change 5 sample return mission. The stationary lander is equipped with a radioisotope heater unit as well as solar panels in order to heat its subsystems and power its operations during its planned 1-year mission. It has a scientific payload of 7 instruments and cameras. In addition to their lunar scientific roles, the cameras will also acquire images of the Earth and other celestial bodies. During the 14-day lunar nights, the lander and the rover will go into sleep mode. On the lander, the scientific instruments consist of an optical ultraviolet telescope for astronomy, an ultraviolet camera to monitor space weather, and a descent camera to monitor the landing. The rover Jade Rabbit has 2 panoramic cameras, engineering and navigational cameras, an arm-mounted alpha particle X-ray spectrometer to analyze chemical elements in the rocks and soil, an infrared spectrometer to study minerals, and ground-penetrating radar to map the structure of lunar soil and crust down to several hundred feet. Change 3 was launched on the 1st of December 2013 atop a Long March 3B rocket flying from Launch Complex 2 at the Taiwan spaceport. According to some news reports, homes downrange of the launch center were damaged during liftoff when spent hardware wreckage from the rocket, including one piece the size of a desk, fell onto a village in Shayong County in neighbouring Hunan province. The county authorities had moved 1,600 people to safety before the liftoff, while more than 200 people near the launch site in Chuan had been moved to a primary school hall. The first and second stages of the March 3B separated according to plan, and 15 minutes later, Change 3 was in Earth orbit. The Change 3 spacecraft then separated from the launch vehicle before the probe spent the next 5 days travelling towards the Moon. orbital satellite, lying at a mean distance of 239,000 miles, and it takes just over 27 days to orbit around our planet once. In terms of size, the Earth is 7,926 miles in diameter, compared to that of the Moon, which is 2,168 miles. Therefore, the Earth is 80 times more massive than the Moon, so that the Earth-Moon system can be best considered as a double planet rather than a planet and a moon. The Moon is a splendid sight as she moves through the star patterns of the constellations each night, and there is much that the amateur astronomer can see even with a pair of binoculars. The dark plains, known as seas or maria, are easy to view as they make up the appearance of the man in the moon. The eventual landing site of Jade Rabbit is on the Mare Imbrium, which is Latin for Sea of Rains, that is marked by the left eye, and is one of the most spectacular sights on the moon near sunrise, when the floor is in shadow and the nearby Montes Dura mountains range are illuminated. The probe entered a 62-mile circular lunar orbit on December 6, 2013. The orbit was obtained after 6 minutes of variable thrust engine braking from its single main engine. Chang'e 3 began its descent from the lowest part of its orbit, 9 miles above the Moon's surface. During its descent to an altitude of 1.2 miles, deceleration reduced the lander's speed from 1 mile a second orbital velocity to 0. 2,000 feet above the lunar surface, the automatic landing sequence cut in, setting Chang'e 3 on course for landing without further control from the Earth. However, the probe was slightly off target, since it had drifted a little to the east before the craft's thrusters compensated. A brief pause was taken at an altitude of 300 feet to further refine the approach. Once the landing site was chosen autonomously, Chang'e 3 slowed and descended to an altitude of 12 feet, about 4 meters, at which point the rocket motor cut off and the lander fell the rest of the way, landing on the surface with impact-absorbing legs. The planned landing site was announced to be Sinus Iridium. However, the lander descended on Mare Imbrium about 25 miles east of the 3.7-mile diameter crater Laplace F at 44.12 60 degrees north, 19.50 14 degrees west on December 14, 2013. On December 18th, the Chinese Zhenghe news agency reported that 6 out of the 8 pieces of scientific equipment deployed to the Moon with the Chang'e 3 lunar mission had been activated and are functioning properly, according to scientists working on the mission. Speaking at a news conference, scientists said that the equipment aboard the U-2 lunar rover and the Chang'e 3 lander had so far been functioning as hoped, despite the unexpectedly rigorous conditions of the lunar environment. Except for the alpha particle X-ray spectrometer and the visible and near-infrared imaging spectrometer, the instruments have all been activated and are undergoing tests and adjustments, said Su Yan, Deputy Designer of the Chang'e 3 Ground Application System. Zhang He, Deputy Designer of the probe, said that although the temperature disparity is greater than scientists had anticipated, all the equipment on the Moon is in perfect condition and optical and ultraviolet imaging experiments are underway. Scientists with the Ground Application System are expecting to receive a colossal quantity of original data from the rover and lander, which have independent channels to send signals. Su said the earlier Chang'e 1 and Chang'e 2 craft only had one channel each. On December 20th, China's moon rover, Jade Rabbit, continued exploring after a sleep, according to the State Administration, Science, Technology and Industry for National Defense. At 8 p.m. Beijing time, the 6-wheeled rover started moving again after shutting down its subsystems on December 16th. U2 has had to deal with direct solar radiation, raising the temperature to over 100 degrees centigrade on his sunny side, while the shaded side simultaneously fell below zero. The break had been planned to last until December the 23rd, but the scientists decided to restart U2 now for more research time based on the recent observations and telemetry parameters, said Pai Yahoo, spokesman for the lunar program. The Jade Rabbit landing site is currently in darkness with the sun below the horizon, with lunar sunset being on December the 26th to sunrise on January the 10th. Therefore, Chang'e 3 and Jade Rabbit are currently having a nap before the real scientific work begins later this month. From the landing site, the Earth is always above the horizon. Its angular size is 2 degrees of arc, so our home appears 4 times larger than that of the full moon, as seen in our own sky, and it is quite brilliant, shining at magnitude -17. Earth also shows phases during the period of 1 lunar month. For example, it is full on January the 1st, 2014. Also, since the moon is in orbit around our Earth, Jade Rabbit can view all of the Northern Hemisphere constellations each month. The constellations of winter are on view at the moment, then spring on January the 6th, summer on January the 14th, autumn on January the 22nd, and we are back to winter at the end of the month. Now what about eclipses of the sun and moon? As viewed from the moon, the Earth's eclipses are reversed, so that the total lunar eclipse of April the 15th will be a date to look forward to. At 0746 UT, Jade Rabbit will see a total eclipse of the sun by the Earth, while here on Earth, amateur astronomers will see the moon's disk turn dark orange. 2 weeks later, on April the 29th, Jade Rabbit will see the moon's shadow crossing the southern hemisphere of the Earth during the annular eclipse of the sun. On this occasion, observers in Australia will see a large partial eclipse of the sun, while the full annular eclipse will be visible over the Antarctic. While the astronomical community is still waiting to see the first analysis of the rocks and lunar soil, Jade Rabbit began sending back self-portraits and images of the surroundings soon after the rover rolled on to the lunar surface. The rover mission is planned to last a year until January 2015, during which time it will send back some exciting information. So what do we know about the Jade Rabbit landing site from past space missions? NASA's spacecraft Grail was launched on September the 10th, 2011. It consists of 2 lunar probes which are studying the moon in unprecedented detail. Grail A, known as Flo, reached the Moon on New Year's Eve 2011, while Grail B, known as Ebb, arrived on New Year's Day 2012. The two solar-powered spacecraft are flying in tandem orbits around the Moon to measure its gravity field. The first results were released in December 2012, and they are quite remarkable since they also include topography information from NASA's Lunar Reconnaissance Orbiter, LRO. The Lunar Reconnaissance Orbiter was launched to the Moon on June 18, 2009. The measurements match those found by seismic data at the NASA Apollo 12 and 14 landing sites, where crustal thickness is 19 miles. There is a minimum crustal thickness less than 0.6 miles within the near side of the Mare Crisium. The average thickness of the whole of the Moon's crust is 21 miles. The data from Grail shows that the thickness of the Moon's crust at the Jade Rabbit landing site is 7 miles, which is the same as the whole of the Mare Imbrium Sea. Grail also looked at the Moon's mascons, mass concentration areas, by creating a gravity map of the Moon. Very precise microwave measurements between the two spacecraft, named Ebb and Flo, were used to map gravity with high precision and high spatial revolution. Red corresponds to mass excesses and blue corresponds to mass deficiencies. This Grail map shows that the gravity field at the Jade Rabbit landing site is 300 milligal, which shows up as a red area, which is one of the mass concentration areas of the Moon. The Gal is a unit of acceleration, sometimes called Galileo. Symbol Gal, G-A-L, which is used extensively in the science of gravimetry. The Gal is defined as 1 centimeter per second squared. The milligal, therefore, refers to 1/1000th of a gal. Another NASA spacecraft to study the Moon in great detail was Clementine. Clementine was a joint project between the Strategic Defense Initiative Organization and NASA. The objective of the mission was to test sensors and spacecraft components under extended exposure to the space environment and to make scientific observations of the Moon and the near-Earth asteroid Geographos. The observations included imaging at various wavelengths, including ultraviolet and infrared, laser ranging, altimetry, and charged particles measurements. Clementine was launched on the 25th of January 1994. After 2 air flybys, Clementine went into orbit around the Moon on February the 21st, and lunar mapping took place over 2 months. The spacecraft took hundreds of high-resolution images of the Moon during this time. Sadly, after leaving lunar orbit, a malfunction in one of the onboard computers on May the 7th caused the thruster to fire until it used up all its fuel, leaving the spacecraft spinning at about 80 revolutions a minute with no spin control, which ended the mission. Clementine data shows that the level of iron at the Jade Rabbit landing site is about 9% by weight, which is consistent with the lunar seas on the near side of the Moon, in comparison to the heavily cratered lowlands, which are 4%, and titanium was also found to be in abundance. Further information about the Jade Rabbit landing site in the Mare Imbrium, which is 25 miles east of the crater Laplace F, can only be ascertained from what astronomers have identified from the formation of the Moon 4.5 billion years ago.
Craters and other formations appear to be permanent now, but the Moon didn't always look like this. Thanks to NASA's Lunar Reconnaissance Orbiter, we now have a better look at some of the Moon's history. The Moon likely started its life as a giant ball of magma formed from the remains of an impact on Earth about 4.5 billion years ago. After the hot material collected into a sphere, the magma began to cool, eventually forming a crust on the surface of the Moon with the magma just underneath. Around 4.3 billion years ago, a giant impact battered the Moon's south pole, forming the South Pole Aitken Basin and sending debris as far as the opposite side of the Moon. This impact marked the beginning of a period that would cause large-scale changes to the Moon's surface. One by one, more huge collisions shaped the terrain. some forming large basins that would eventually fill in to become the dark-colored patches of the moon, known as Maria. They began as normal craters, but soon started to change due to the size of the impact on the relatively thin crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through the cracks caused by the impacts. The resulting volcanic activity spread lava throughout the craters, gradually filling them in and cooling. Because of the high iron content of the basalt in the rock, the Maria reflect less light and therefore appear darker than the surrounding highlands of the moon. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The moon continued to be battered by other impactors, although they were much smaller than the objects that formed the largest basins. Some of the largest, most recent, and best-known impacts from this period include the Tycho, Copernicus, and Aristarchus craters, which are unique due to the complex system of rays that stretch out from the impact site. Finally, we arrive at the moon that we see today. Though the surface continues to be affected by impacts, the rate has slowed down drastically to the point where the moon appears unchanging to the human eye, as a permanent record of its own history, and a glimpse of how craters may have formed here on Earth.
Oh, hey! There is orange soil. Well, don't move it till I see it. Hey, it is! I can see it from here. It's orange. Fantastic, sports fans.
A team from Brown University, Carnegie Institution of Washington, and Case Western Reserve University report the first finding of water in lunar melt inclusions. Given the high concentration that we found, it shows that lunar magmas have the same concentration of water as those that we found on some lavas that come from the upper mantle of the Earth. Last year, people found evidence for water on the surface of the moon in the permanently shallow craters. The question came from the origin of that water, and the consensus was that it was produced by cometary material impacted on the surface of the moon. Our finding suggests that another possibility for the origin of that water could be the magmatic degassing. That means that that water didn't come from outside the moon, but it came from inside the moon. Our finding questions some aspects of the giant impact event that generated the moon. We expect that during this giant impact, you will have a significant loss of volatiles. What our finding seems to suggest that there are regions of the moon that has significant amount of volatile. That's not well supported by the giant impact.
Say a light yellow tan, then probably orthopyroxene. It's fairly coarsely crystalline.
The assignment that Alberto gave me was to sort through this glass that was returned by Apollo 17 and notice the little details of it, which included these little clear olivine grains with melt inclusions in them.
Tom came one day and said, I found something really different. So when I look at that, I realized that what Tom found were the melt inclusions.
The lunar melt inclusions are important because they've trapped water and other volatile elements from within the lunar mantle. They provide a window into the conditions from which these lavas erupted.
And then I said to Tom, do you know what you found? He said, you found something that will be published in Science.
It was a huge surprise for me when he told me that I just found this little millimeter-sized rock that was gonna change the way we think about the moon. And it's really exciting to be involved in something that it appears will be so significant.
In 2008, we reported the first evidence for the presence of water in the interior of the moon. And we predicted that areas within the moon will have concentration of water that will be equivalent to the upper mantle of the Earth. In 2011, we have proven it.
It is very fortunate that the March 3B rocket worked well and that the Jade Rabbit rover landed in a lava field in the Mare Imbrium, because we need to study the basalt rocks here to confirm that water is present, even in tiny quantities. This will help to show whether the minor planets in the asteroid belt or the moons of the major planets contain large quantities of water ice. Questions are now being asked, will it be a Chinese or American astronaut that will next step foot on the moon? Will NASA and China cooperate to build the first lunar spaceport and perhaps send the first manned mission to Mars? We will just have to wait and see. Even so, the opportunities are there. I have just time to mention the BBC Sky at Night programme is having a break this month. When the series returns in February, it will have a new presenter, space scientist Dr. Maggie Aderin-Peacock, who will join existing presenter astrophysicist Chris Lintott. The show will have a new half-hour slot on BBC4 and will be available soon after on the BBC iPlayer catch-up service. Maggie is a research fellow at the University College London Department of Science and Technology Studies and an honorary research associate in the Physics and Astronomy department. On behalf of all our regular viewers, I would like to welcome Maggie into her new role and wish her lots of best wishes and clear skies. That's all we have time for this month. Thank you for watching. If you would like to contact me, my email address is richard.pearson53@yahoo.co.uk. You can find our website at astronomytvprogram.blogspot.co.uk, and please follow me on Twitter. The next programme will be available from January the 31st, so please make a note in your diary. Until then, goodbye for now.